Hello, everybody, and welcome to your amazing lesson on Hubble's Law and the electromagnetic spectrum. You by Edwin Hubble. So Edwin Hubble was a famous astronomer, made lots of contributions to astronomy, and Edwin Hubble came up with something that proposes that galaxies are moving away from each other at a speed that is proportional to their distance. So what that means is as their distance increases, their speed also increases. And this is important because it relates to the electromagnetic spectrum. And since we're dealing with light, we're dealing with the light of different galaxies, the light of stars. We're able to look at the electromagnetic spectrum, look at different wavelengths to tell whether objects are moving towards Earth or red light has the longest wavelength. So if you're looking at the same diagram from the last slide, you're going to look at the very top where you see the words increasing energy and look at the actual squiggly lines. Those squiggly lines are they are the wavelengths. So if you look at the very bottom where you see the colors, you see the color red. If you look up to the squiggly lines, the wavelength for red, they're far apart. So that's a long wavelength. If you look all the way at the left-hand side where the wavelength, the color is purple, you can tell that the waves are closer together. So the wavelengths are shorter on the left-hand side at gamma rays, and they are longer on the right-hand side, which is the radio waves, which is the red. So again, to summarize, violet or blue light has the shortest wavelength. And if you look down to the wavelength, the shorter wavelength has the most energy. And so what that means is that the waves are occurring more frequently. So if you're thinking about waves in the ocean and you're standing in the ocean and waves are continuously crashing upon you, crashing, 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 it means there's not a lot of time in between each wave, which means that there's a lot of energy. Whereas if you go all the way over to the right-hand side on the right, if the waves in the ocean were taking a lot of time to crash in between, it means maybe you're just floating along. There's not a whole lot of energy compared to when the waves are crashing constantly. Here is the same diagram, just expanded for you so you can see it close up. So you see, again, increasing energy is the short wavelengths. So all the way to the left side of the screen, the top left, you see the peak, which is the top of the wave. There's not a lot of space. That means the waves are happening really fast. On the right-hand side, there is space between the peaks. That means the waves are not happening really fast, and so there's less energy. So to summarize, when an object moves toward the Earth, the wavelength will be shortened. Okay, so it's coming towards Earth. The wavelength is shortened and the color will be violet or blue, so it has more energy. When it moves away from Earth, think of something stretching away. The wavelengths are going to get, the frequency between the waves is going to get farther apart, and therefore the color will be red. So anything moving away from Earth, and we're talking about light, so any kind of light moving away from Earth will exhibit a red color. Anything moving towards Earth is going to exhibit a bluish. So again, violet light all the way on the left-hand side has the most energy, that's gamma rays, and red light has the least energy, that's radio waves. And what I just said in the slide before is when something, an object, a celestial object that has light is coming towards Earth, the wavelength is going to be shortened and it's going to have that violet or blue light. When it's moving away from Earth, it's going to stretch out and it's going to have the red light. So there's an effect, and it's called the Doppler effect. That's what describes the change in wavelength of light or sound that happens when an object moves toward or away from you. And That is the sound that you hear when a train or an ambulance passes you. So you hear that sound like, that is the Doppler effect. And I'm not a master at the Doppler effect, but I do have a really awesome video that we're going to look at or watch in class that has some really great sounds to show you examples of the Doppler effect. So when the object is moving towards you, let's say it's an ambulance, it's moving towards you, the wavelength is getting closer to you. So they're going to be shorter. And then when it moves away from you, as shown in the diagram, the wavelength is going to get farther apart. It's going to stretch out. So astronomers don't deal with sound, but the Doppler effect works also with light. And so we know that the Doppler effect with an ambulance, we can hear it because when an ambulance passes us, we can hear it getting louder, and then we can hear it kind of stretching away and getting fainter as it passes. Same thing happens with light, with objects that are moving towards or away from us. So again, astronomers don't really care about sound, but they really do care about changes in light wavelengths because it allows them to see whether objects are moving towards or away from Earth. And really big shifts in the Doppler indicate high speed. And so there's a term called the redshift. A redshift means that an object in space is actually moving away from Earth. And the redshift goes back to the electromagnetic spectrum and the type of wavelength. So redshift again means a long wavelength. It means the object's moving away. The redshift in distant galaxies tells us that the universe is actually expanding. So again, this is building on the Big Bang theory that the universe is still expanding from that initial Big Bang from the singularity. So to end our lesson, greater redshifts in the color spectrum of distant galaxies indicate faster speeds. And so the farther away something is, the faster the speed is going to be. And if you look down at the arrows, the arrow that's on the right-hand side is red. It is indicating that that object is moving away. The left-hand side is blue. It's indicating that that is moving towards, which indicates that objects in the universe are still expanding.